In this video, we're going to talk about radical functions. A radical function is a function of the form f of x is equal to the nth root of x. So, I've provided two examples of radical functions. Recall, the domain of a function is the set of domain values for which the function is defined or is a real number. Now, we talked earlier that if the index is even, then the radicand must be greater than or equal to 0 in order for the expression to be a real number. So for instance, if I do the square root of 25, I know that's a real number because that answer is 5. Square root of 0 is a real number because I know that answer is 0. But if I have a negative under a square root, we know that is not a real number because there's no value times the same exact value that will get me to negative 49. Now, when the index is odd, then the radicand can be any real number for the expression to be a real number. So for instance, I know the cube root of 8 is a real number because that's 2. We know the cube root of 0 is 0. And even if I stick a negative underneath, our answer is still going to be a real number. All right, so let's write the domain of each radical function in interval notation. So the key for this is to be able to identify whether the index is even or odd. Here, because there's no number for the index, we assume it's 2 because it's a square root. Well, 2 is an even number. So here's what we'll do. We will stick the radicand and make it greater than or equal to 0. That will guarantee that whatever value I have underneath the square root will be a real number. So solve, and then divide. And in the graph, and I can write that in interval notation. So any value that is greater than or equal to 9/7, when I plug in, will be guaranteed to get me a real number that comes out. All right, let's take a look at the next example. Because here the index is odd, it does not matter what value is under this particular radical, I'm guaranteed to have a real number. So the domain is all real numbers because the index is odd. Okay, I'm going to write one other example below now. So here I have the 10th root of 5 minus x. Because the index is even, again, I will write what is under the radicand and set it greater than or equal to 0. So solve the inequality, subtract the 5. Now, when I divide by a negative 1, I must switch the inequality sign. And a negative divided by a negative is a positive. So I can graph this on a number line. And then I can write that in interval notation.